And welcome back, students. We are now going to be talking about, in this lesson, peripherals. So let's get started. So, if you recall, in our previous lesson, we discussed the basic components of a computer. Now, this lesson, we're going to explore peripherals. A peripheral, for our purposes, by definition, is an ancillary device used to put information into and get information out of the computer. Now, there are three basic types of peripherals. You have input devices, you have output devices, and hybrid devices that can perform both functions, such as a touchscreen. So, they're both, outputting information, but they're also capturing it. So let's start with the first one, input. So recall, an input device is something that takes user input and passes it as data to the computer, such as a mouse or keyboard. Examples of input devices include, but are not limited to, a computer mouse, a keyboard, a microphone, webcams, digital cameras, game controllers, etc. Pretty much anything that you think of that you are interacting with to get something from the computer. Now, input devices are typically categorized by two different things. First is the modality of input. So is it mechanical motion? Is it audio? Is it visual? Mechanical motion, they go like, for example, a game controller. You're moving your joysticks or you're pressing a trigger. Those are mechanical motions. Audio would be something like a microphone. It's capturing you dialogue. Like right now I'm doing the screen recording. The microphone is picking up the audio data. Visual. All right, if you're using your camera, like on your smartphone, you take a picture. That's a visual input. All right. Then the other thing is whether it's using discrete or continuous input. So discrete would be something like a key press, which is you press and it's done. Continuous input things like mouse movement position. So even though yes, it's kind of, that's a little more gray. It's something like, even though it's actually not a true continuous input when we're looking at mouse movement. For our purposes, we can kind of think of that because it's looking for a band of time versus a single press or keystroke. So let's look at the first input device here, a keyboard. Now, a keyboard is a human interface device, which is represented visually as a layout of buttons. Look at your keyboard right now. You can agree, I think, with that definition that it is a layout of buttons. Now, those buttons, of course, have different labels and stuff like that, but it is still a keyboard. Now, each button is used to input a character or call upon a function of the computer. Now, you can look at the keyboard, like right now, I can see I have a QWERTY laid out keyboard. QWERTY, of course, meaning QWERTY is in the top row there. I have, numbers. I have special characters like exclamation point. I can access. I can have the backspace key, which is a function. Also, I have my F1 through F12 keys, which are, of course, are directly mapped functions. Now, each button's function, so whether it's a character or it's calling something, is controlled by the control unit CPU. So that CPU is going to call it from BIOS or from the operating system of what that is, but the CPU handles the logistics. The buttons, in turn, act as the main text entry for users. So if I want to input my name, or I want to input anything really as text, the keyboard is going to be my main means of doing that. I mean, yes, you can use like on-screen and stuff like that, but ultimately, the physical keyboard in front of you is probably going to be your main text entry for that. Now, of course, traditional buttons are usually spring-based or they're mechanical in their nature, though newer buttons can utilize things like virtual or projected keyboards. Virtual keyboards, of course, are the ones that pop up on your screen. And a projected keyboard would be if you had looks like it projects almost out like a little holographic kind of keyboard. And what it does, it uses sensors and stuff to determine where the light break is to really help judge what key you're pressing. All right, let's talk about pointing devices. Now, input devices that are used to specify a position in space are known as pointing devices. Quick examples here include mice, tracking pads, and touchscreens. Now, pointing devices are categorized by the following: whether the input is direct or indirect. Direct meaning that the input space coincides with the display space, so that's your touchscreen. Or indirect, such as your mouse. So where your mouse is moving, doesn't have to be, because you can pick your mouse up and move it to and it can keep going from where it was at. So it's not a direct correlation. And whether the informational is absolute or relative, which is just built on what I just said here, you'll notice there's a lot of correlation here between direct and indirect and absolute and positional. So the absolute is touchscreen, because where you're physically touching that screen is where that cursor is physically going to be. Or it's relative, like I said, you can pick that mouse up, you can move it, and you can kind of continue your cursor with it. There's not a physical correlation for where the mouse is necessary for the keyboard. Yes, the mouse can track that thing across the keyboard, but if you pick your mouse up, set it back on your desk, the cursor doesn't necessarily move, but you can keep that cursor moving from where you left it off. All right, let's continue talking about pointing devices. These are the most commonly used input devices today. This human interface device allows the user to input spatial data to the computer. Spatial data meaning, space up, for example, your screen. Where is it at? In the case of both the mouse and a touchpad, this is done by detecting movement across a physical surface. Now, analog devices such as joysticks achieve this typically by reporting to the computer an angle of deflection. So think about a gamepad controller, and you have your joysticks. How does it detect movement? Well, you put, for example, if you want to go forward, unless you have inverted, you push down, and if you angle those joysticks forward, your character moves forward. Pull back and move backwards. So it's an angle of deflection from its zero state that the joystick reports that. Now, movement of the pointing device are echoed on the screen, typically by movement of a pointer, right, such as your mouse cursor, to create an easy way to navigate the computer's GUI. Next, let's talk about video and audio input. Video input devices are used to digitize images or video from the outside world into the computer, which can then be stored in multiple formats depending upon the user's requirement. Now, audio input signals are used to capture sound by allowing users to send audio signals to the computer for processing, recording, or carrying out commands. Devices such as microphones allows users to speak to a computer in order to record things like voice message, you can do software navigation, or even perform speech recognition. So there's multiple things. Not simply just like, hey, I'm going to record myself talking. You can also get commands, like, for example, if you ever use like the AI assistant on your phone, so whether you use like Google, Siri, Cortana, whoever, if you're talking into that phone, it's listening to it, and what it's doing is helping to navigate to whatever information you're looking for. That's some speech recognition there. Next up are output devices. An output device is something that takes data from the computer and outputs or prints it into some medium of display, typically things such as a monitor or a printer. Now, examples also include things like monitors, projectors, printers, speakers, headphones, etc. An output device can display information that is text, it can do graphics, it can do tactile, it can do audio or video. Let's talk a little bit about those output forms. Text consists of characters that are used to create things like words, sentences, paragraphs. I think it's a pretty straightforward thing, what text is. Graphics, of course, are digital representations of non-text information, such as things like drawings, charts, photographs, and even animation. Now, tactile output is things such as raised line drawings, which may be useful for some individuals who are blind. Audio is things such as music, speech, or any other sound. And then, of course, video consists of images played back at speed to provide the appearance of full motion. Remember, video is not truly a constant motion. It's actually more a series of images that our eyes process the information to create the illusion of movement. All right, graphical output. Yay, video games. A digital image is a numeric representation of an image stored in a computer that doesn't have any physical size, really, until it's displayed on a screen or printed on paper. Until that point, it's just a collection of numbers in the computer's hard drive that describe the individual elements of the picture and how they're arranged. Now, some computers come in with built-in graphics, while others require a graphics card or graphics adapter board to be added. And unless the computer has graphics capability built into the motherboard, that translation is going to take place on the graphics card no matter what. Now, if an image has fixed resolution, it is what's known as a vector or a raster image. These are also sometimes called bitmap images because it's literally you're mapping out the bits to represent data. Raster images are composed of pixels and are best suited for things like photorealistic images. Compare that to vector images, which are composed of lines and corners rather than dots, and more suited to things like art, graphics, and font. So you have two things. You have raster or vector. Raster images are typically not the ones you want to use if you're doing computer editing because they don't stretch well. That's how you get the distorted images. Well, the vector images, they tend to resize pretty nicely and keep the image you want. Now, if you make a 3D image, the graphics card typically first will create a wireframe out of straight lines. Before it rasterizes the image, it fills in remaining pixels and adds lighting, texture, and color. Now, let's talk about the tactile output. Now, haptic technology is a tactile feedback technology which takes advantage of the sense of touch by applying things like forces, vibrations, or motions to the user. Right, so think about like your phone vibrating. Now, several printers and wax jet printers also have the capability of producing raised line drawings. So that would be, for example, a 3D printer would fall here under tactile output. There are also handheld devices that use array of vibrating pins, to present a tactile outline of the characters or text under the viewing window of the device. So that falls into the thing we talked about for the blind. All right, next up, sound output. Speech output systems can be used to read screen text to computer users. Special software programs known as screen readers attempt to identify and interpret what is being displayed on the screen, and speech synthesizers convert data to vocalized text or sounds. Audio input devices also produce music, speech, or other sounds. All right, and that's everything, folks. Until next time.